Technology in 2026 didn't move slowly, it exploded. Engineers pushed materials, precision, and miniaturization so far that everyday gadgets started to feel like prototypes from the future. Some were brilliant, some controversial, and a few so advanced that regulators couldn't keep up. This video isn't a guide or a tutorial. It's a cinematic look at the engineering, the craftsmanship, and the wild innovation behind 25 gadgets that crossed the line simply because they were too perfectly engineered. If you're ready for polished metal, hidden mechanisms, and insane design breakthroughs, let's dive in. Switchblade knife. Modern switchblades evolved into precision-built mechanical art pieces. Instead of heavy steel slabs, engineers began using aircraft-grade aluminum frames paired with titanium liners and ceramic bearings that allowed the blade to glide with liquid smoothness. The torsion spring systems inside these knives no longer felt like simple coiled metal. They were tension balance mechanisms that deployed the blade so quickly and cleanly, it almost felt electronic. Every inner surface is polished, the pivot is micro-machined, and even the lockup is engineered to click into place with a tactile finality that screams premium craftsmanship. You don't feel metal grinding, you feel crisp, controlled mechanical movement. AR-15, Armorer's Wrench. This tool is a masterclass in industrial engineering. A single piece of reinforced steel with torque points, precision-cut slots, and multi-fit geometry machined so tightly that it locks onto components with zero slippage. The wrench doesn't just grab hardware, it interfaces with parts through multiple contact points to evenly distribute force, protecting threads and preventing deformation. Heat treatment hardens the structure, while the design incorporates leverage optimization so that even tough components rotate smoothly. The edges are chamfered for comfort, the grip surface is textured for control, and the entire tool feels like something built for a professional aerospace lab. 10-round AR magazines. Although they look simple, these magazines are complex mechanical systems built from advanced polymer blends reinforced with glass fibers for rigidity and impact resistance. Internally, the follower glides along a carefully polished track shaped to eliminate tilt, and the stainless steel spring delivers consistent tension at every compression stage. Engineers model the exact angle of the feed lips so each round sits at the perfect presentation height, minimizing drag and maximizing reliability. The internal geometry is tuned through computer simulations, making each cycle smooth and repeatable. Even temperature-resistant materials are chosen to prevent swelling or warping. The engineering inside feels almost excessive, a tiny, compact storage device tuned like a performance component. But the next device takes mechanical motion to a theatrical level. Bike license, plate flipper. This is mechanical showmanship disguised as a mounting bracket. Inside is a hinge system built with hardened pins, reinforced arms, and a microservo, or spring lever mechanism engineered to rotate a plate smoothly in one controlled sweep. Rubber dampers eliminate noise, while the hinge geometry ensures the movement stays aligned without wobble. The body is shaped to blend into the bike frame, making the entire mechanism feel like it belongs inside a premium automotive accessory. It doesn't rattle, it doesn't jam. Everything rotates with a confident, smooth snap. It's elegant, subtle, and engineered with surprising attention to detail. And while this gadget hides identity, the next device is built to reveal things most people can't see. Hidden camera detector. A hidden camera detector operates like a pocket-sized optical scanner. Engineers built them using high-intensity LED strobing rings calibrated to bounce sharp reflections off tiny lenses, even lenses less than a millimeter wide. Add a microprocessor that filters ambient reflections and isolates repeating signatures from optical glass. And suddenly you have a tool capable of spotting micro cameras in cluttered environments. Some detectors integrate RF filters that scan for unusual transmission spikes, packing surprising sophistication into a palm-sized device. The whole board is layered to minimize interference, and the power system is designed to keep the LEDs bright without overheating. It's precision crammed into a pocket. Tablet pill press. Tablet presses are mechanical choreography in metal form. Engineers design them with hardened steel dies, torque balance bearings, and compression pistons capable of applying thousands of pounds of pressure in perfectly synchronized cycles. The cam system moves with refined timing, pressing material into uniform shapes with machine-like consistency. Surfaces inside are polished to reduce friction, and the motion path is engineered to eliminate wobble, so every tablet ends up the same thickness, density, and finish. Even the hopper flow is regulated to ensure equal fill distribution. Flamethrower-style device. Despite the dramatic name, this device is pure controlled engineering. Inside is a pressure-regulated chamber that balances output, a valve system that manages flow rate, and a heat-resistant nozzle machined from aluminum or coated steel to withstand extreme temperatures. The ignition system uses high-voltage electrodes spaced to create a consistent arc, ensuring stable combustion. Airflow channels inside are shaped to maintain flame coherence, and safety interlocks help regulate pressure. UNIDEN BEARCAT 125AT. This compact scanner is basically an RF lab in your hand. Engineers constructed it around multi-layer circuit boards with gold-coated microtraces that reduce electrical noise. The antenna system is tuned to sweep various frequency bands with surprising sensitivity, while filters isolate usable signals from the noise floor. A digital signal processor cleans up the feed, minimizing distortion and stabilizing output. Internally, components are arranged to prevent interference and maintain temperature balance. Everything is meant to capture faint signals with clarity. But if receiving waves is impressive, thus the next gadget can reshape them entirely through software-driven electronics. HACKRF 1 PORTAPACK H2. This device is a showcase of flexible engineering. Built as a software-defined transceiver, it uses a wideband radio front end paired with a high-speed analog-to-digital converter and a frequency-stable oscillator that keeps signals clean. The internal processor can reconfigure how the device handles radio waves, allowing it to analyze, transmit, or modulate signals, depending on configuration. Its power efficiency, noise shaping, and signal clarity represent some of the most advanced engineering in portable RF tools. All that capability fits into a compact frame with a clean screen interface. It's impressive, and the next device hides equally advanced tech inside something everyone sees daily. Power outlet hidden camera. This is stealth engineering at its finest. Engineers packed a micro lens, sensor array, storage module, battery, and control board into a housing barely larger than an outlet plate. Ventilation slots are disguised as screw holes. Cooling is managed through thin heat dissipation polymers molded behind the faceplate. Ribbon cables are folded neatly to maximize internal space. The lens often uses a wide-angle polymer optic designed to remain invisible at casual glance. All this sits behind a matte finish shell that blends perfectly into any wall. High-power green laser pointer. Inside the sleek tube sits a diode-pumped solid-state system, where an infrared diode fires into a nonlinear crystal that converts light into intensely bright green output. Engineers align correcting lenses within micrometer tolerances so the beam remains tight across long distances. Heatsink structures wrap around the diode to prevent temperature spikes, ensuring consistent output without distortion. The result is a beam so crisp it almost feels physical, a strand of neon cutting across the night. Even the power path is regulated through stabilized circuits. But while lasers enhance visibility, the next engineering breakthrough enhances heat-based detection. Compact thermal imager. Thermal imagers rely on microbolometer arrays, grids of tiny sensors that detect infrared radiation. Engineers mount the array on shock-absorbing platforms and pair it with germanium lenses that focus heat signatures with remarkable precision. Behind the lens sits a fast-processing chip that converts temperature differentials into detailed visuals. All of this is wrapped in a compact, heat-managed shell designed to disperse excess warmth without distorting readings. Some units support multiple color palettes, edge sharpness algorithms, and microshutters for calibration. Shrinking all of this into pocket size is astonishing, but the engineering leap of turning darkness into visibility is matched only by what the next device does. Advanced Night Vision Unit. This device amplifies the faintest light using an intensifier tube containing a photocathode and a microchannel plate that multiplies electrons thousands of times. Engineers improve durability by refining coatings and adding shock resistance. Image sharpness is enhanced through multi-coated optics, and power consumption is reduced through optimized circuitry. The results are stunning. Environments that should be pitch black suddenly appear as detailed, high-contrast landscapes. Even motion looks smooth, thanks to improved refresh components. But if amplifying darkness feels futuristic, the next gadget bends sound itself into something unrecognizable. Advanced Voice Changer. This is not a toy. It's a digital audio processor that reshapes speech using real-time formant shifting, harmonic blending, and pitch mapping. Engineers built it around specialized DSP chips capable of analyzing and rebuilding voice patterns on the fly. The output doesn't sound robotic. It sounds clean, natural, and eerily accurate. Housing design minimizes microphone feedback, while cooling layers ensure the chip stays stable during continuous processing. Interface controls are smooth and responsive, and the internal architecture ensures low latency. It's voice engineering at a level that feels ahead of its time. And just as voice can be reshaped, the next device reshapes aerial movement with precision. Stealth Surveillance Drone. This drone is a marvel of modern miniaturization. A carbon fiber frame, silent brushless motors with magnetic levitation properties, vibration-dampened mounts, and a control board that fuses data from gyro, accelerometer, and camera sensors in real time. Propeller blades are sculpted to reduce turbulence, and the body uses matte finishes to avoid reflections. Engineers tuned flight algorithms to maintain stability, even in tight spaces, all while keeping noise to a whisper. It's smooth, precise, and incredibly quiet, an engineering feat that almost feels unfair. But if drones can see from above, the next device sees from eye level, without anyone noticing. Spy camera glasses. These sleek glasses pack more engineering than meets the eye. A microlens sits hidden inside the frame corner, aligned behind tinted glass. A ribbon cable connects the lens to a razor-thin control board embedded in the arm. Ultra-thin batteries power the system without heating, and the design uses heat-resistant plastics to maintain comfort during extended wear. Everything is molded to look indistinguishable from premium eyewear. The weight distribution keeps the glasses balanced so they feel natural. It's wearable engineering that looks stylish but hides surprising capability. And while glasses conceal visuals, the next gadget packs a punch of raw stored energy. High-capacity lithium-ion packs. These packs rely on advanced layered anode and cathode sheets coated with high-efficiency compounds separated by ultra-thin membranes to maintain ion flow. Engineers added microcontrollers to balance current, monitor temperature, and prevent overcharge. What makes them stand out is energy density, more power in less space thanks to improved cell chemistry. Lightweight casings dissipate heat effectively, and internal paths are reinforced to prevent swelling. When optimized correctly, these packs deliver smooth, stable power. But pack enough pressure in a small container, and you get the next device. High-pressure aerosol paints. These cans are pressure vessels in disguise. Reinforced steel walls contain high-energy propellants that force paint through precision valves, engineered for consistent spray patterns. The nozzle geometry is fine-tuned to atomize paint evenly, and internal linings prevent chemical reactions. Engineers regulate internal pressure to maintain force, even at low temperatures. The efficiency is stunning: clean lines, high output, and powerful coverage. But pressure isn't the only thing that raised eyebrows. Even cosmetics became unexpectedly engineered. Pure-grade acetone remover. This industrial-strength solvent is refined through multi-stage distillation that removes impurities until the formula becomes incredibly potent. Engineers balance evaporation rate, purity, and stability, so the liquid dissolves coatings almost instantly. Because of its volatility, the containers use thick, chemical-resistant plastic and tight seal caps. Despite being marketed for beauty, the engineering behind purity and potency makes it a shockingly powerful chemical. But while this is chemistry, the next gadget is mechanical art, BRNA-SD. This platform feels like a premium mechanical tool. Its body uses composite materials reinforced for durability, with internal chambers designed for pressure management. The sequencing system is engineered for smooth cycling. And magnetic feed alignment keeps everything consistent. Grip ergonomics are sculpted with precision, and the entire assembly feels like a high-end engineered device made for controlled, stable performance. But precise mechanics take another form in the next tool, one that hides behind realism. Realistic FIREARM replica lighters. These lighters are engineered with molded polymer shells, metal rails, and components shaped using high-resolution steel dies. Surface textures mimic real materials, and the weight distribution is carefully planned to feel realistic in the hand. The ignition system sits neatly inside a realistic frame, with metal inserts, keeping the structure sturdy. The finish uses multi-step texturing processes to create an authentic look. But while realism can fool the eye, invisibility fools everything. Magnetic micro earpieces. These tiny devices contain microspeakers, nanomagnets, and microchips embedded into resin capsules. Engineers designed them for near-total invisibility, with induction loops powering them wirelessly through neck transmitters. The clarity is impressive, considering the size, smooth audio, low heat, and stable performance. Even the magnets are shaped to fit comfortably without shifting. It's miniaturization taken to extremes. And speaking of compact engineering, the next device flies with stealth and style. VELCASE drone. This drone folds using tension joints engineered to snap open smoothly and lock securely. The carbon fiber arms keep it feather light, while the propellers are sculpted to generate minimal noise. Internal stabilization technology uses sensor fusion to keep flight steady. The matte finish reduces reflectivity, and the body is shaped for efficient airflow. Despite its size, the drone feels premium, agile, and refined. But while this machine moves forward, the next one shifts shape entirely. PROVOKE Axe. The PROVOKE Axe is a kinetic marvel. Its folding system uses linked pivot arms that rotate in perfect harmony, guided by machined internal tracks. Each component is cut from robust steel or aluminum and polished for smooth movement. The blade locks with a mechanical confidence you can feel. The entire structure is engineered to transform from compact to ready state in one continuous motion. It's like holding mechanical origami sculpted from metal. And as impressive as that is, the final gadget takes engineering invisibility to its absolute limit. Hidden audio surveillance bugs. These micro-devices condense astonishing engineering into a fingernail-sized frame. Inside, engineers fit a microphone, amplifier processor, wireless transmitter, and thin-film battery. Antennas are printed directly onto the circuit board. The entire layout is optimized so tightly that every millimeter matters. Heat is managed through micro-venting and low-energy chipsets. The result is a device so compact and refined, it feels like science fiction, a complete audio system engineered to vanish into the environment. It's the peak of microscale craftsmanship. These 25 gadgets didn't spark controversy because of intention. They sparked it because the engineering behind them outpaced everything around them. This breakdown wasn't about using anything. It was about understanding the craftsmanship shaping tomorrow's technology. If you want more cinematic deep dives into cutting-edge gadgets and future-grade engineering, hit subscribe, stay curious, and stay sharp. I'll see you in the next one.